Here's part 2 for day 11 of Advent of Code. In the previous part, we sort of built up this seating arrangement with some understanding of how we thought people would pick seats as they arrived on the ferry. But in part 2, we realized we've made a little bit of a mistake. It turns out that people don't look at the seats immediately adjacent to them, the 8 seats immediately adjacent to them. They actually look at the 8 seats in sort of their line of view in each of those 8 directions. So on the sort of cardinal north, south, east, west directions, and then along the diagonals. So with the example we have here, this empty seat L is in the line of sight of 8 occupied seats. So we can follow it along there, here, that sort of thing. Whereas with this one, this seat is in the line of sight of one other seat and it's empty. So basically the sort of occupied seat counter that we built in the previous example needs a little bit of adjustment. And yeah, I'm not going to dig through any of these examples, but given our sort of example starting layout from part 1, we're going to see if we can move towards an answer like 26. And if we can, then we'll plug in the big output. So I will copy, maybe not. I will save this as part2.rb. And now we can make some adjustments. So we'll jump back to the sample. And then, yeah, like I said, it's this seat counting that's going to need, like the occupied seat counting, that's going to need some adjustment. These neighboring positions are unfortunately no longer valid. We're going to actually need to think about this in a different way. So instead of just looking at these 8 spots, I want to think of them as directions, and so we'll name them. So we'll say it's we have A, B, C, D, oops, oh boy. A, B, C, D, E, F, G, H. So those are our directions, just kind of going around clockwise, I suppose. So if we were to start with A, we will see that A could potentially be this position that's x minus 1, y minus 1. But really the 1 is sort of variable here because we're going to want to sort of follow along the diagonal until we find a seat. So we're going to want to, I guess, have some sort of loop. So, yeah, like while yeah, maybe we can find a position using like a catch block again. Position found, seat found maybe. And then something like this. And so our condition is that we have some sort of n that starts at 1, or sort of like xn equals 1, and then yn equals 1. And so, yeah, let's see. While that's a little bit tricky to think about. What are the conditions we could run into that would jump us out of here if our like seating chart x minus xn, y minus yn equals a seat or equals an empty seat, then we would break out. If it equals nil, we break out because we've run off the edge. And if x minus xn is negative or y minus yn is negative, then yeah, we produce nil, and in this case we would produce like a 0 or a 1 based on whether it was the pound or the L, because we're counting occupied neighbors here. So I guess these aren't nils, then these are zeros, right? No neighbor found in that line of sight. And then I guess the other case is if this equals a dot, an empty seat, then we like keep looking and we increment xn and yn. Okay. So I think this is kind of moving me in the direction of something I can work with. So let's see. Yeah, while true, do, and get rid of that. And we'll say the x position is x minus xn. The y position is y minus yn. And so we will throw seat found with 0 if x dot pos negative or y pos negative. Oops. So if either of those is negative, then we'll return 0. That's what we described here. Yeah, what's next? If we end up with these positions leading to a null spot, then that will be an issue as well. So we'll grab that. Oops. X pos, Y pos. So if that's nil, then we'll throw seat found 0. Actually, yeah, let's stick this in a in some sort of variable here. So found seat equals this thing. And so if the found seat is nil, then we throw. If the found seat is equal to this, then we throw seat found 1. Having some typing issues. Seat found 1. And then we'll do something similar. Seat found 0 if it's an empty seat. And then otherwise we've found this dot, and so we'll keep looping. Do sort of an explicit next, even though that'll next on its own. Yeah, we know it's an infinite loop, but we don't expect it to truly go on forever. Cool, so that's kind of a version of how we would find whether A is occupied or not. I would love to generalize this though, something that we could do for any of them. It's sort of this thing that needs to change for each one. Like, what if we could say like the like A finder is a proc. Let's see. Ruby proc with arguments. Yeah, perhaps something like this, I guess. And so what would A need to know to it would need to know kind of what the what these two functions were. Right? Are they minus? Yeah, I guess it could be 0, negative, or positive. So like, what are the xn's? Xn, Yn. If we call those negatives, then these can be addition. And so then we can call yeah, what if we call this generalized finder? I think it's Xn, Yn. Those values, it returns something eventually. Yeah, I think we're onto something here. That's the catch. Blah, blah, blah. Yeah, this will find our value, and that's what we want to return. Here's our end. Yeah, let me comment on all of that, because I think all that's going to go away for now. And so then we get down here, and A finder is going to be generalized finder -1, -1. Yeah, okay. And then we can just do those, and so it's A, B, C, D, E, F, G, H. And so we can kind of go off of these numbers now. So -1, -1, -1, 0, -1, +1. Then we're going kind of around the clock. So now 0 + 1. And now down to here, so +1, +1. And then +1, 0. And then +1, -1. And then lastly, back to 0, -1. Okay. And so if we do all of these, and then I guess this is getting a little bit sort of verbose, but I think we can still work with it. So if I paste all of these here into an array of sorts, and then if we map those into calls, then we should find out what each of them are, and then we can call sum on them, and that's what this thing should return, is the sum of all occupied seats. Got an extra comma there. So it's a little bit, I think, tricky to reason about. But yeah, let's see if this works. Oops. Ruby part 2. Undefined method. Oh, whoops. So we have to call these. Probably not necessary to use oh boy. Yeah, I think we found our infinite loop, or found ourselves stuck in one. So let's break out of that. Oh, I see what's happening. We have x pos equals x, y pos equals y, and then these just need to be plus equals. Otherwise, they're never actually getting incremented. Well, that broke a little more quickly. Call for map undefined method call for 0 integer on line 91. Oh, we don't have to map over call now. These are just something that we can sum up again. Awesome. Let's, yeah, and these aren't finders. These are just, those are just those values. So we can just use them directly. $23. I don't think that's 26. Okay, so that's not quite right. Was I off on any of these? Let's, I guess, double check them. Copy that down here. So A is -1, -1 from X. B is -1, 0. It's -1, 1 for C. Then we've got D, which is 0 plus 1. E is 1, 1. F, which is 1, 0. Then we've got 1, -1 for G. And then is 0, -1 right? Yeah, 0, -1 for H. So that seems solid. Did we get the logic up here right? Yeah, negative's no good, so we didn't find a seat. Otherwise, the seat we found, if it's nil, 0, if it's open, 0, if it's occupied, 1. Otherwise, keep looking. That's the same thing. So, what could we be missing? Something's up. Well, we can pry in and see if we can debug this count by looking at an example. So, oops. So we're in the pry, we've got our grid. So what if we say grid dot, can't remember the name of our methods, count occupied neighbors. Neighbors, and then for what position? Well, how about 1, 1? We expect it to be 0. Okay, now what if we say grid dot occupy all seats? Okay, grid dot display. Okay, and now count for 1, 1. I'd expect it to be 1, 2, 3, 4, 5, 6, 7. We'd expect it to be 7. Okay. That feels good. What about 0, 0? We'd expect to be 1, 2, 3. Okay. So this seems to be mostly working. How about this position here? 1, 2, 3, 4, 7, 8, 9, 10. 2, 3, 4, 5. Yeah, so what about 9, 9? Do we get 3 again? Yeah. What about 8? What about 8, 4? Do we get 8? I think this is working. Did they give us a different input here? Given the same starting layout as above. No, this is what they gave us above. "26 occupied seats." Oh, I think I missed a rule. It now takes 5 or more visible occupied seats instead of 4. Oh boy, okay. So let's get rid of all that. I think we've got our solution, and the 4 just needs to be 5. There's our 26. And now if we say input.txt instead, let it run for a while, we see it kind of iterate down. 2,111. Do we have another gold star? Yes, we do. All right. 2 gold stars for the day. Awesome. Well, thanks for watching.